Welcome to our latest MKS ESI webinar production. It's always an exciting opportunity when we get a chance to talk about the latest innovations in flex drilling. Today's webinar focuses on how Flex PCB manufacturers can leverage CapStone's spot-on upgrade feature to increase their competitiveness by improving the quality of blind vias to increase yield. We're excited to have Casey Krueger, the MKS Director of Product Marketing for Flex Solutions, leading our webinar today. Thank you for joining us. We hope to see you in our future webinars. And now I'll hand over the presentation to Casey.
Thanks, Ryan. Hello, everybody. As Ryan mentioned, I'm Casey Krueger, Director of Marketing for our Flex PCB Systems. We'll go ahead and jump right in, and I'll briefly cover the agenda for today. As Ryan mentioned, we're going to focus on the spot-on feature upgrade for our CapStone systems and how they can optimize or improve your yield of your operation. So the brief agenda here is we're first going to cover some laser fundamentals. It's important to understand the importance of spot quality and some of the challenges with maintaining proper focus of the laser. We'll talk about some of the leading causes of failures for vias. And then we'll go over the CapStone spot-on feature and relevant benefits as well. And I certainly want to highlight what's required to install spot-on if you have a field upgrade. It's going to be available both as a field upgrade and on new systems. But if you have a field upgrade, I want to briefly cover what's required there. And then we'll open it up for question and answer session. With the question and answer session in mind, I do want to cover some brief logistics for the webinar. All the participants are in listen-only mode. So if you are trying to ask a question audibly, we won't be able to hear you. Please ask the questions in chat. So use the chat function, should be on, I think, on your right-hand side. And then at the end of the webinar, we will go through those questions. We also have some questions that were asked when people registered. We'll also cover those questions. We'll try to get to as many questions as we can, given the time allotted. We do plan to stick to about 45 minutes total. If you want to listen to this again, or you want to share it with a coworker, a recording will be available, and we'll have a link available for that on our website or sent to you via email. All right, again, so I encourage you to ask questions, use the chat function, and we'll either answer them at the end or answer them via email. So I want to start the presentation just at a high level, give you an overview of the advantage of this feature upgrade spot on. Most of the focus will be on the presentation will be on how spot on will enable higher yield in your operation. We are able to do that by ensuring that we maintain the optimal beam focus at the panel surface. This is enabled through several ways, which we'll cover throughout the presentation. The first one being we have improved our ability to measure the quality of the beam. It's an automated method and allows us to maintain a superior focus accuracy during processing. We are coupling that with two other features. One is the ability now to map the Z height across a panel or your work surface. And I should say not only the Z height of the panel, but also the panel, the overlay, and the chuck. And then we combine that with our ability to dynamically control the height, the Z height of the panel surface during processing. And in the end, all these features added together will optimize the process for drilling vias and give you higher yield. So as I mentioned in the agenda, I did want to just touch briefly on some laser processing fundamentals. primarily relative to the importance of focus and spot quality, and why that is so important. So the top graphic here, labeled A, shows a laser beam. So typically the laser beam coming out, obviously the laser will go through a beam expander and then hit some optics. In this case, it's shown as a lens, an optical lens. And then you can see it forms a nice Gaussian beam profile. And you can see within the Gaussian beam profile a focal plane or focal point or a spot. And you see the spot there in orange. So that is very critical when processing work surfaces with lasers. And we're obviously going to spend a lot of time on that today. The bottom graphic that's labeled B, this displays the kind of intensity distribution, or even the fluence, which is the energy per unit area. And that's why it's so important to control and know where the focal point is, or the spot is, and be able to maintain that ideal focus so you can maximize that fluence control, the amount of energy you're applying to the work surface. So if I was to rotate this, just to show another visual example, and this is more in line with our via drilling systems, where the laser is obviously perpendicular to the work surface. So here I've rotated that nice Gaussian shape 90 degrees, and I've drawn here a cross section of a panel. And you can see where the orange spot again is the spot of the laser. And we want to control and know where that spot is hitting the surface of the panel. And if we're able to do that, we're able to control to a greater extent the processing capabilities and the yield of a given process with our systems. And another way to highlight the importance of knowing the spot location is in this graphic that I've displayed here. So this shows an exaggerated Z height fluctuation across a panel. Again, not only the panel, but obviously the chuck or vacuum table, the overlay on top of the chuck, and then the panel itself. And this shows what can happen if you have a large amount of Z height fluctuation across a panel that you can't really accurately predict, if you're not measuring it, where that focus beam is going to be during processing, and therefore potentially cause issues. So speaking of issues, some of the most common via drilling failures that we see in our experience working with customers, we've really identified three primary yield issues associated with processing of flex PCBs. The first one is polyimide residue. So this is they've tried to clear out a blind via, and the polyimide residue remains and would cause a yield issue in manufacturing. Another common one is top copper remaining. So in the processing, they use the via or use the laser system to drill through that top copper layer and didn't get enough energy applied to remove all the copper, and there's some copper remaining in the via. Another common cause of yield failure. And then, hold on one second. Sorry. Then the third would be bottom copper damage. So this would be you're processing maybe with too much energy, and you're actually damaging that bottom copper layer. All three of these failure modes are really directly affected by the spot quality and our ability to accurately focus the beam. And by automating and improving on the focus calibration, and spot quality, we're able to greatly reduce the causes of these yield failures. All right, with that, I want to jump into Spot On and talk about some of its unique features and how they will benefit your operations. There's really three new features that are introduced with Spot On, and we categorize or group those features within two complementary subsystems. The first one being beam quality. So we are now able with Spot On to automatically measure and calibrate the quality of the beam. So that certainly gives us a big advantage of knowing the spot characteristics. So things like circularity are measured over time and collected, and then the calibration itself is also done on a routine schedule, and that schedule can be set by the customer. The other subsystem that I mentioned is the topology and focus compensation. So topology is that panel Z-height mapping, the ability to identify where those high or low spots are on the panel. And then the second area is, once you have the panel height, is being able to dynamically adjust during processing with real-time Z control. So let's go into a little bit more detail on each of these three areas. All right, so focusing on beam quality, Spot On provides the best beam quality available on the market today. There are a few methods that we should go through while reviewing both competitive methods that are used today across our fleet, and methods, and obviously the method that we are currently utilizing today with Spot On. So the first method here is material ablation. So this is a very old process. It's still widely used today. It has some significant challenges with it. Is that one, that it's manual. It's not automated in any way. It's very operator dependent. It's also highly material and system dependent. It's very operator dependent. It's prone to errors. And it doesn't really allow for a good system-to-system consistency, especially if you have a fleet of systems. If we go to the next level, a better approach is using the beam view camera. So this is, you have the ability to use the camera to take pictures along the beam path. Great, you're actually looking at the beam, so that's a big positive. However, the issue is when you're measuring for the circularity or general quality of that beam, it's highly susceptible to error depending on where along the beam path you're measuring. There's also some user error associated with this. In addition, because you're taking it along the beam path and not at the work surface, not at the panel surface, there is going to be some error involved in that. In addition, you may be taking out some of the optics closer to the work surface. This is actually a pretty significant risk because those optics that are closest to the work surface are the most susceptible to damage caused by debris, contamination. So again, wouldn't be a fully accurate picture of the characteristics of the spot. And then finally, it really can't be used to identify the true focus height of the position. So a better method is with spot on. And so spot on, it uses an optical test method. It's automated. It occurs, this is the most important part, it occurs at the workpiece, so at the surface of the panel. And it can more accurately determine the ideal focus, while also at the same time, it's collecting this information and recording it, logging it over time. So you'll have access to that information later. If we look at it from the standpoint of accuracy and how much better is this method, the current method, if we use the camera, laser to camera focus method that we mentioned, that's kind of our middle of the road option that I presented on the previous slide. We think that's accurate approximately about 100 microns. While spot on, with the new feature and hardware that we've included, it's accurate to about 10 microns. So much more accurate spot characteristics, and will over time certainly improve the performance of your system. I alluded to earlier that we are collecting these spot metrics over time, all the characteristics of the spot, things like circularity, spot size, focus location, and we are creating with spot on process control charts. They're automatically created, automatically populated, and what they allow you to do is evaluate and monitor any changes in the spot, any deviations from the mean. So this is, system to system. There would be various deviations in spot quality, and this allows you to record that information and access it if by chance you have a processing yield issue. This data set's available. These charts are available for you to reference to see if spot quality potentially was a cause of that yield issue. And I should mention this data is not actively provided in these type of process control charts on any of our other systems. So we talked about beam quality and the way that we're able to ensure beam quality, calibrate the spot, and now we need to talk about the other elements of spot on, and that is the topology and the focus compensation. So with spot on, we are now able to accurately map the topology or the Z height across the entire panel. This mapping can be performed on a customer prescribed interval. For example, every panel, every 10th panel, each first panel of every lot. There's a various combinations that a customer can decide to choose depending on their process. Our general recommendation, though, is to perform this just on the first panel. Through the testing we've done internally and the evaluations that we've done on customer sites, is within a given lot, the first panel is sufficient, and the variations from panel to panel within a given lot of product doesn't vary enough to merit mapping every single panel. I should also mention that there is a throughput hit if you decide to map every single panel, because the system is taking the time, although it is fast, it is taking the time to map each panel. And we obviously want to avoid negative throughput hits. So we suggest mapping the first panel of a lot. Any new job, especially if you're changing, let's say, the overlays underneath the panel, or if your material type, if you're manufacturing a different process, you're going to want to run that Z height mapping on that first panel of the lot. So we do have the ability, on the previous slide I was showing a single panel map. We do have the ability to map every single panel. As mentioned, this isn't something that we generally recommend, but it is possible, and this does give you an added potential benefit in that it provides you with a set of data on the consistency of the panel topology, across a lot that you're manufacturing. So certainly is possible. We've actually had some customers that have chosen to do this, but again, we don't feel like it's necessary for most applications. So as I mentioned, the frequency of the mapping is user defined. I've got a quick snapshot here of the user interface. And as you can see here, when Z mapping is enabled, so tracking mode is enabled with panel mapping, you can see on the UI here that you have the option to change various characteristics to how frequent, or if you want to do it every 10th. That's all within the control of the user. So the other key element of Spot On is the focus compensation. So we are able to dynamically focus the beam based on that Z height mapping information that we record. The graphic I'm showing now, it displays what can happen. It's obviously an exaggerated view, but it can show what can happen when the focus point of a beam doesn't properly account for the height variations across a panel. And I should say a panel overlay or chuck, or in this case, it's labeled as vacuum table, but we use those interchangeably. So this does rely on some of the pre-setup of the system before processing, where typically a customer will take an average of the height variation and make some setting changes on the focus, usually using a Z height change in the manufacturing process. But that is prone to error because you aren't looking at the entire panel. You're being selective and you're taking an average. So it certainly is not as accurate. And now with the graphic I'm showing on the right, with Spot On, since we're able to dynamically change the height of the panel during processing based on the mapping data that we took before, we are able to change where that focus point is to more closely match what is expected in the processing and really generate much higher yield and less poor quality vias. As you can see in this example, we look at focus variance across a work surface. I've got an estimate here of about 150 microns across a work surface. I would say that's maybe an average. We've certainly seen less. We've actually seen much more. It really depends on what you're processing, whether it's something with thicker copper, multi-layer, materials like that typically are going to have much higher variations across the work surface. All right, I wanted to show a graphic of that. Actually, there's a video that shows what is happening. So what we have here is a 3D map of a panel where we've added some shims under the panel. So you see these somewhat exaggerated heights, and the line that you see, let me actually go back. I apologize, I want to play the video. Let's see if I'm able to do that. All right. Looks like I'm not able to do that, but all right, I apologize for that. So without replaying the video, what it's doing is the actual line is following the customer's recipe and is the processing line, if you will, of all the different features across this panel that need to be drilled, right? So where the vias are, or routing is, or whatever the case might be. And then you can see how it follows over the relevant high spots and low spots. And so it's a visual example of how it works, combining the Z mapping with the ability to dynamically control the location of the spot. Another benefit that I wanted to mention is regarding to lot setup time. And Spot On has some significant benefits to the current methods that are used today in setting up a system for processing new materials. So generally, the inability to accurately and effectively correct for panel height variability has been a direct cause for the development of really large process windows. So a large process window allows you to account for some of those variations. Sometimes that will cause a hit to maybe processing speed. But many of our customers have developed some best practices in setting up these systems, and one of the practices that we know a lot of customers use, not all, but many customers use, is they verify the focus process window by taking measurements across several different locations on a panel. So the visual I'm showing here shows a panel where they're taking 5 measurements across the panel. In contrast, with Spot On, we're able to reduce the number of locations that needs that requires the process or focus check. This will allow customers to potentially greatly reduce the amount of setup time or evaluation of process window quality. Again, depending on if they're going from 5 to 3 or 4 to 2, it really depends on the process. And again, this is somewhat dependent on customer by customer basis and their internal processes for how they set up the systems and their respective process windows. But we have found that because of our ability to maintain a focus through mapping the Z height and adjusting where that spot is on the panel work surface, not as many process window checks are required. I wanted to show a real world example from one of our customers. So this is an example of some of the testing that was done with Spot On. So the image on the left here obviously shows a Z map where it calls out high points and low points as they were mapped across a panel. Again, I keep referring to it as panel, but keep in mind it's mapping everything, right? It is mapping the surface of the panel, but it's taking into account the overlay and the chuck height variations as well. And what the customer did is ran the process twice for these select panels. Once with the Z mapping function turned on, so taking into account the various mapping high points and low points, and then ran it off and ran it on. So ran it on, takes into account obviously the high points and low points, and then turning it off it does not. And as you can see, they were able to produce all good vias, even in this really high point that you see here, where we would have expected to either have some copper damage or PI residue remaining due to the height variations in that part of the panel. So I did want to cover some of the system requirements and what's included when you purchase Spot On. So I guess take a step back. So just to reiterate what I said earlier, and I guess I have it here on this first bullet, but Spot On is available as a field upgrade. So if you have a CapStone system today and are interested in this technology, you can get a field upgrade kit that can be installed by one of our field service engineers. It's also a configurable option now for any new CapStones that are ordered. In that case, you don't have to worry about the field upgrade. It'll come shipped with all the necessary hardware and software to run Spot On. From a system software perspective, this functionality actually is built directly into our system software, but you have to have a current version, so 4.5 or greater. The other key element is that the system must be upgraded to Windows 10. System not currently on Windows 10 can upgrade to Windows 10. It's actually a pretty simple process. It would likely require, or it does require, a RAM upgrade, but that is included if you purchase a Windows 10 upgrade kit from us. Then from a hardware perspective, so it is both a hardware and software solution. The Spot On kit itself includes two sub-assemblies. The first one is something we call a beam characterization tool, or we use BCT for short. This is mounted to the chuck of the system, and this is what we use to measure the characteristics of the spot. So again, that is done on a reoccurring basis, right? It's not done during processing. The actual spot quality is only checked periodically because the spot quality is very slow to deteriorate over time. So you really only need to check that at a certain interval, say once a week or once a month, something like that. A longer period of time is required or is suggested, I should say. The other element is the cap probe assembly. So the cap probe is what allows us to measure the topology of the panel. So again, this actually could be run before processing every single panel, but there would be a hit to throughput doing that. So we recommend that Z height mapping, that's what the cap probe enables, that is run just on the first panel of a given new lot. And then the other element, which I should mention, all these elements come together in the kit. So hopefully this isn't misleading the way we structured this slide, but it's all included in the kit together. But the other element here is a upgraded manifold, and that is made to just connect all these various pieces, all the new pneumatics to make this function properly. And then there also, with the upgraded manifold, there is gives us the ability to have an actuated debris exhaust valve, which is an important feature for Spot On, because it allows us to maintain when that debris exhaust valve is open and closed during processing. All right, with that, I did want to run through and just highlight again, some of the key advantages for Spot On. So again, the primary benefit for Spot On is an improvement in yield for your processing. We expect to achieve higher yield, again, by being able to ensure that we are maintaining the beam focus as close to the panel as possible. So we are able to reduce some of those yield excursions that we highlighted earlier, the polyimide remaining in the via hole, the damaged copper, and other common forms of yield issues. And we're able to do that again by taking those spot quality measurements, recording that over time. Those process analytic charts that I mentioned will be available for reference. If there is some sort of quality issue, you can find out if that's related to spot quality. But even just as important, we are able to automatically calibrate the ideal focus position with spot on. And then the final two that are really used in concert is that panel Z height mapping. So being able to map the topology of the panel, again, not just the panel, but we're also looking at the variations from the panel, the overlay, and the chuck. And then obviously correlating that to your recipe and the process, and being able to dynamically change the height of the panel, the Z height, based on your recipe, so we have better beam control and better quality product in the end. So thank you. I appreciate everyone's time listening to this. I'm sure there's lots of questions. We'll get to the questions here in a moment. If you have very specific questions relative to your application, we'd be interested in hearing those. We've got multiple beta sites that we ran this through, so we've got experience in running it through various different materials. But certainly welcome any questions you might have. So I'm going to spend some time going through questions. Some of the questions were sent when people registered, so I'll cover those questions first, and then we'll run through the questions that were brought up in chat. I do want to highlight that if I don't get to your question, that we'll follow up again via email or through your local account team to make sure all your questions are addressed. All right, Ryan, should we open it up for questions? All right, give me 1 minute here. Transition to opening up to see the questions.
Casey, can you see my screen?
I can, yes. I think we're good. Thanks. Okay, so like I said, I'm going to answer a few questions that came up when people registered. So first one here is spot on measuring over the entire table or for the panel, i.e. would smaller panel sizes help throughput? So the first part of that question, which hopefully you know the answer now, but I'll be more as specific as I can. So spot on is measuring the panel or the work surface. It's not necessarily measuring the entire table or chuck. If you had a panel that covered the entire chuck, it would measure that entire surface. But whatever the size panel that you're using, that is what it uses as reference to what it will be measuring. And then to go even further, it's also referencing, if you remember the graphic I showed, which I unfortunately wasn't able to play again, but that showed the line going over the topology of a panel. So it also uses your recipe, right, to know what areas of the panel to map. So another important aspect. So the second part of your question is, would a smaller panel size help with throughput. So I think we would have to know more about, precisely what's behind your question there. I mean, generally smaller panels are processed faster. But if you're compressing all of your given features, into a smaller panel, it wouldn't necessarily process faster. So it's really dependent on several things, right? Obviously the material type, via size, the materials you're actually using, the through vias, blind vias. There's always obviously a myriad of variables that go into actual throughput size. So I think if you'd like to explain that question in more detail, we can certainly go into a more detailed response if we understand exactly what you mean by it. I mean, generally smaller panels are processed faster than larger panels, but it's dependent again on all the features that you're processing. All right, is there a chance for a 5335 Xi to upgrade to this ability like CapStone? I'm paraphrasing there a bit. So currently this is only available on CapStone, both CapStones in the field and new CapStones being purchased from us. Obviously, new systems being manufactured can come with this option as well. Yeah, so the answer currently is no, and we'll see if there's a demand in the market for other systems, and then we'll consider that as they come. Another pre-meeting question was, how long does it take to map panels? So again, so this has a lot of variables to it, but generally it's less than 60 seconds. It depends again on number of features, size of the panel, things of that sort. But I would say with some of the customers that we've been working with, their average is really closer to 20 to 30 seconds. So that's what we've seen as being more common, at least in the customer sites that we have so far. All right, let's go to some of the chat questions. All right, first question here is about the setup time for system operators. Again, I'm paraphrasing a bit. So the overall setup time is very low. This feature is meant to run in the background where all that data collection I mentioned is just automatically happening when you have spot on the system and it's enabled. There's a lot of configurable options. Again, once you configure it, it's going to run, and that's going to be how it's set up for your given recipe. So if you're configuring it to run the first panel of a lot, that's what it will do. Operators shouldn't need to mess with it unless they're fine tuning and making adjustments on the process. So again, it's supposed to it runs in the background, very, very light on any kind of increase in setup time. Next question is about maintenance, because obviously, so there's hardware. And they also ask about cost of potential maintenance that this might add to the system. So there really are minimal added costs. So this only has one, the spot on only has one consumable part. That part is about $400. We expect that part, we refer to it as a BCT coupon. So again, this is part of the system that is measuring the characteristics of the spot and then also allowing us to calibrate the spot. And that costs about $400, and we expect that coupon to last about a year. So costs would be about $400 a year, and the replacement of that coupon would occur during one of the PM visits. Another question about, this one's about 5330. Is it available on 5330 systems? No, it's not. Does it come standard with CapStone? No, it does not. It's a configurable option. So you can include it in a new CapStone, or you can choose not to. There's a question about cost. How much does it cost? So we don't list publicly our list prices, and because this is a webinar that we make publicly available, I'm not going to provide list price during the webinar. However, our local salespeople would be happy to share this information, not a problem. So if you want to get an idea of the price to upgrade when you're CapStones, they will help you out. So with that, I think we are out of time. We're at just a little over 45 minutes. I wanted to stick to 45 minutes. I know there's a couple of questions here that I didn't get a chance to answer. We'll get followed up with you guys as soon as possible on those. So again, appreciate you participating in the webinar, and I hope you have a great day. Thank you.